So we're beginning for Probability Activities Chapter 3. This is Probability Lesson 21A. And we're beginning to look at tree diagrams where the probabilities are not always exactly the same. In other words, we have unequal outcomes, trees with unequal outcomes. And so in this particular problem, we have two dartboards, and we're going to look at each one separately and then draw our tree diagram to represent the probabilities of hitting combinations of the two. So we think of throwing a dart at this one first and then throwing a dart at this one second. So first event, second event. And you can see from the dartboards that there's not an equal chance of hitting A or B. In fact, A has a much more likely chance of being hit than B does because it's larger. In fact, I'm just going to go ahead and write the fractional part. This is 3/4 of the space for A and 1/4 of the space for B. And so if we were to throw a dart at this one and think of it as we do a tree diagram, this first part of this first set of outcomes, you're either going to hit the section A or you're going to hit the section B, but again, it's much more likely that you would hit section A. It's 3/4 of the time, and only 1/4 of the time would you hit B, since the outcomes are unequal, and this represents that first dart being thrown and the probability of hitting the A or the B. And then we move to the second dart board and look at each part, and just thinking of the sections that we have here. I'm going to divide this one up a little bit more so you can see that it really represents, if we were to think of A as and all these parts here, that you could divide it up into all these little pieces. That section A is 3/8, 1, 2, 3, 4, 5, 6, 7, 8, 3/8 of the entire dartboard. And B is 1/8 of the dartboard. And C is 4/8, which is 1/2 of the dartboard. So now we have three different things, three different probabilities. And when we think about doing the probability, the next stage of this tree diagram, if we had hit A on the first one and then we just look at the different parts, the A or the B or the C, for the second one, you have to think about the probabilities of each part. It'd be 3/8 for the A part, 1/8 for the B part, 1/2 for the C part. And we're going to get to how to use those in just a moment, but it's important as you do tree diagrams, especially with unequal probabilities, that you list these outcomes on the branches as you go. We'll come back to that in just a moment after we finish B. If we'd hit B the first time, we still would have the opportunity to hit the A, the B, or the C. And again, the probabilities of hitting each of those is 3/8, 1/8, and 1/2 for each part. And then as we look at each outcome, for instance, this branch here, A, then A, and then this one, B, A, then B, and then A, then C, and here we have B, then A, and then B and B, and B and C. So those are all our outcomes, but the chances of getting each of these outcomes is not equally likely because of the unequal outcomes or the unequal probabilities in each of the parts. So let's actually calculate the probability of each part. See, there are 6, but this is not a 1 in 6 chance because it's not equally split up amongst all of the different parts. So we're going to have to take each fractional part, in this case 3/4 for the first part, times 3/8 for the second part, and this will give us the actual probability 9 out of 32 for that particular part to get A then A. 9/32 is the probability of hitting A twice, this A and this A. If we look at the next 1A then B, we have 3/4 and 1/8. So we're going to multiply the 3/4 times 1/8. Take each fractional part and multiply them together because we have multiple probabilities, and it actually multiplies the probabilities together. 3/4 times 1/8 is 3/30 seconds. 8 times 4 is 32. 3 times 1 is 3. And then if we look at AC, this branch, we have 3/4 times 1/2, which is 3/8. And you can see that this one actually is the most likely in this case because of the C being the largest portion. So this fraction is the so far. If we go down to the lower section, do the same thing. We're going to take the fractional parts and multiply them together for each section. So 1/4 times 3/8 for this one. And we get 3 times 1 is 3. 4 times 8 is 32. So 3/30 seconds for B then A. And then B then B is 1/4 times 1/8. The 1/4 times the 1/8, which equals 1/32. And again, that's the least likely because you have the B's both being the smallest portions of each of the two dartboards. And so those are your least possible outcomes. And then your last one, B, C, 1/4 times 1/2, or 1/8. Since the C is half, you actually have a fairly good chance of hitting the C. Not quite as good a chance because the B is smaller. And so there are your 6 different probabilities. So you have 9/30 seconds, 3/30 seconds, 3/8, and really I could put them all in terms of 30 seconds if I wanted to, so there's an easier way to compare them. So that would be 12/30 seconds, and this one would be 4/30 seconds. And you can see that if we add all those up, the 9, 3 is 12, and 12 is 24, 25, 26, 27, 28, and 4 is 32 30 seconds. So it does add up to the entire probability when you put them all on equal denominators. But we still want to reduce fractions to simplest form when we can. So this shows that unequal probabilities lead to unequal outcomes. The most likely outcome in this case is going to be the A, then the C, because the fractions in those cases are that you can see the 12/30 seconds is the most. 3/8 is more than any of the other fractions in this set. And so that's trees of unequal outcomes in the first example. Now there's a second example on this one, but we just have a single spinner. But we're going to spin it twice. So we want to see what the probabilities are of getting different combinations if we do this twice. And you can see that A and B are the same size. They're each 1/4 of the spinner, and C is 1/2 of the spinner. So when we start doing our diagram, we could get A, B, or C on the first spin, and that could be 1/4, or will be 1/4, 1/4, and 1/2 are the probabilities. And then on the second spin, same chances, same options, A, B, C, A, B, C, A, B, and C. And again, the probability is 1/4, 1/4, 1/2, 1/4, 1/4, 1/2, 1/4, 1/4, and 1/2. And you can see there's going to be 9 outcomes. AA, then AB, then AC, then B and A, and B and B, B then C, C then A, C then B, or C than C. So there are 9 outcomes, but they are not equally likely to happen. And you can probably sort of see by the fractions how some of these will be more likely than others. And we're actually going to calculate the fractions through. So the first one, AA, is 1/4 times 1/4, which is 1/16. And the second one is also 1/4 times 1/4, which is 1/16. And AC is 1/4 times 1/2, which is 1/8. So in that first set, that's the most likely of the 3, and it should be because getting the C is the more likely event to happen. As we continue on into the next one, BA, so we have 1/4 times 1/4, again a 1/16, and BB is 1/4 times 1/4, which is 1/16, and BC, 1/4 times 1/2, or 1/8. So again, we have a similar set of probabilities like we had in the first set. Now things change a bit in the third set because of the 1/2 for the C, but we still, same process, 1/2 times 1/4 for CA is 1/8. And then CB, 1/2 times 1/4, it's 1/8. And the last one, 1/2 times 1/2 is 1/4. A quarter of the time, the expectation would be to get C twice. It's the most likely one to occur. And if we were to put all these in terms of sixteenths, 1/16, 1/16, 2/16, 1/16, 1/16, 2/16, 2/16, 2/16, and the very last one, 4/16, 1/4 of the time. So you can see that's the largest fraction of the set. And if you add them all up, they'll all add up to a total of 16 different, really 16 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 4 is 16. So 16/16 adds up to the whole amount. But again, each outcome has its own specific probability because of the unequalness in the beginning. If all these spaces were the same, all these outcomes would be the same. But since they're not, it creates a whole bunch of different possible probabilities that have to be taken into account through this process of using a tree diagram and multiplying through each branch the fractions to find the individual probabilities for each part. So in this chapter, things are going to get a little bit more complicated, a lot more fraction. You can see this problem took a lot of time and a lot of work just to figure out the probabilities, and so a lot of careful work will lead to correct answers in this chapter. Lots of work ahead.